Hi again, everyone. Mr. Cruze here, working through the 8.1 to 8.4 quiz review. In this video, we're going to finish it up. Number 11 just has you state the restrictions, right? And remember, for now, we don't want our denominator to be 0. So denominator cannot be 0. Remember, we talked about in class that universe-ending paradoxes would ensue if we divided by 0. So make sure that you don't do that. So we need to know when these are going to equal 0. So just set them equal to 0. This one tells you x equals -2, and this one tells you x equals 1. So that means if I were to plug those numbers in, you would end up dividing by 0, and that's a no-no. So it can't be -2 or 1 in this case. 12 through number 17 just ask you to simplify and state the restrictions. So kind of the same thing as this. Now we just have to multiply and reduce things, okay? So this one, I need to know what multiplies to -24 and adds to -2. Well, that would be a -6 and a +4 over what multiplies to 12 and adds to 7. That would be a +3 and a +4 times x squared minus 1 factors very handily, x minus 1 and x plus 1 over x minus 6. Now, we need to look and see what can x not be. This one tells you -3. This one tells you -4. And this one tells you 6. Cannot be those three numbers. Now we can cancel anything. It's in the top and the bottom. So x minus 6 is in the top and the bottom. X plus 4 is in the top and the bottom. And there's nothing else left that'll cancel. So your answer is x minus 1 times x plus 1 over x plus 3, as long as x is not -3, -4, or 6. Not too bad. 13, x squared minus 3x minus 4. What multiplies to -4 and adds to -3? Well, that would be -4 and +1 over multiplies to 12 and adds to -7. That'd be -3 and -4. What can x not be? 3 or 4. Now we can feel free to cancel. The x minus 4's disappear, they're removed, and you're left with x plus 1 over x minus 3, as long as x is not 3 or 4. Okay. 14 we seem to have a little trouble with, so I'm just going to go ahead and multiply the tops and the bottoms together, okay? So 6 times 5 is 30. A to the 4th, B to the 4th. Do not add those powers. A and B are two different things. Over 5 times 3 is 15. A cubed, B squared. Okay? You can already tell me what A and B cannot be. What numbers would I plug in that would cause a problem? That would be 0. Anytime it's a number by itself like this, 0. If you add something or subtract something, that'll be a different number, okay? Now we can feel free to reduce. You know how 30 and 15 reduce. 15 goes into itself once, goes into 30 twice, okay? The A's and B's, I'm going to walk you through this. A to the 4th, that's A times A times A times A, over A to the 3rd, that's A times A times A. Well, you can cancel out anything that's in the top that's also in the bottom. So we can cancel out basically 3 pairs of those, and you're left with one little a in the top. So the a to the 3rd goes away, and you're left with a to the 1st power. Same thing happens with the b's, okay? B to the 4th is b times b times b times b over b squared, which is b times b. All right. 2 pairs of those b's are going to cancel, and you're left with b to the 2nd power in the numerator. So our final answer is 2ab squared, and technically it's over 1, so we don't have to worry about it. A isn't 0, and b isn't 0 either. Okay. 15, you remember in class I said to change this to multiplication? Okay. Yay, typos. How does 2x squared minus 6x factor? You can pull out a 2x, and you're left with x minus 3 over x squared plus 18x plus 81. Well, that factors into x plus 9 times x plus 9, because it multiplies to 81 and adds to 18. Times 9 times x plus 9 over x squared minus 9 factors into x minus 3 and x plus 3. Okay. What can x not be? Let's see. Negative 9, but we already have that. Can't be 3, and it can't be negative 3. Now we may cancel. A 2 and an x, there's nothing really in the denominator that cancels with that. X minus 3 does cancel. The 9 does not cancel, even though there is a 9 here. Remember, that's an x plus 9. It's different than 9. And an x plus 9 does cancel. Doesn't matter which one you cancel out. So, what are we left with? Well, 2x times 9 is 18x over, the only thing in the denominator is x plus 9 times x plus 3, as long as x is not negative 9, 3, or negative 3. Alright, 16 is almost identical, except it's division now. Remember, for division, you have to do the KFC method. Keep, flip, change. When you're dividing fractions, or rational functions in this case. Keep, flip, change. So keep the first fraction. Well, we already know how the first fraction factored. We might as well use our knowledge of what 15 factored into. So it factored into this. Okay. Divided by becomes times because of the change. Flip, we flip this fraction. So basically, how it was factored, we're going to flip that. So this will be x minus 3, x plus 3, over 9 times x plus 9. Okay. Now, what can x not be? You have to look at the denominators, of course. Can't be negative 9. Negative 9. I don't care about this 9. That'll never equal 0. This is negative 9. But also, because this is division, wasn't x squared minus 9 on the denominator to begin with? So that means these two I also have to check, because if they're 0, then that's also going to be a problem. So in this case, it happens to be 3 and negative 3 again. Interesting. You'll notice it just so happened in this case that the restrictions were the same. Now, does anything cancel this time? If you look, there's nothing in the numerator that's shared with the denominator. So this is actually one nice, messy little expression. 2x times x minus 3 times x minus 3 times x plus 3 over 9, you'd put that up front, x plus 9 times x plus 9 times x plus 9, as long as, I'll just go ahead and circle this, as long as x is not negative 9, 3, or negative 3. A little messy. You remember this was a typo. I'm pretty sure this was supposed to be multiply because things actually canceled. Okay. If you wanted to clean this up and put x minus 3 squared, you could do that. If you wanted to put x plus 9 cubed, you could do that as well. All right, x plus 1 over x plus 3 divided by x squared plus 2x plus 1 over x squared plus x minus 6. Remember, keep, flip, change. Keep the first fraction. Flip the second. And change the problem to multiplication. Okay? So let's factor this. What multiplies to negative 6 and adds to 1? Well, that would be a positive 3 and a negative 2. What multiplies to 1 and adds to 2? Well, that would be x plus 1 and x plus 1. So what can x not be? Can't be negative 3 because of this denominator. Can't be negative 1 because of either one of these. And again, because it's division, you have to check the numerator of this second fraction because it was originally in the denominator. So this would be negative 3. We already have that. And this one would be 2. If you didn't check that, you would be missing one of your restrictions. Alright, now what cancels? X plus 1 cancels. X plus 3 cancels. So you are left with x minus 2 over x plus 1, as long as x is not negative 3, negative 1, or 2. And last but certainly not least, number 18, list the points of discontinuity for the rational function and whether they are asymptotes or wholes. Remember, asymptotes is if they do not cancel out completely. Wholes is if it still remain, or wholes is if they do cancel out completely. All right. So let's look. Points of discontinuity, or as some of you like to call them, pods. Points of discontinuity. Yeah, I'm spelling that right. Points of discontinuity you just need to check and see where the denominator would equal 0. It's going to happen in two places, at x equals -6 and at x equals -3. Those are your points of discontinuity. Now, which one of them cancels? Only the one that gives you -3 cancels. That means there's a hole at x equals -3. We also called that removable. So if you happen to see that, removable hole, think about taking dirt from the earth. You're removing it from the earth, it makes a hole. X equals -6, though, is still in the reduced form. So this is a vertical asymptote at -6. Okay. We called that non-removable, if you will. Non-removable. All right. There you go. If you guys have any additional questions, you can comment in these videos, or you can Twitter me, or you can email me at any time. All right. Thanks for watching.